Hello students, secondary 1 chemistry. We are going to continue chemical equations in unit 2. Last period we have studied the symbols and the valences of different elements and atomic groups and used them to write the formulas of many compounds, such as these compounds, chemical formulas of sodium hydroxide, potassium hydroxide, phosphoric acid, carbon dioxide, and so on. And we knew that some elements are known as diatomic molecules: nitrogen, N2, O2, H2. When these elements are present alone without reactions, naturally they are written as N2, O2, and so on. Some physical states: solids denoted by S, liquids L, gas G, aqueous solutions aqueous. We have also learned how to balance chemical equations. This is very important. Why we balance chemical equations? We balance chemical equations to achieve the law of mass conservation. This is the answer. The chemical equation should be balanced to achieve the law of mass conservation. If we want to rewrite this equation, and after balancing them, we put here, of course this is unbalanced equations, for 2 nitrogen atoms, 1 nitrogen atom, 6 oxygen atoms, 5 oxygen atoms, 1 and 2 and 2. This equation is not balanced. To balance it, we put here 2, put here 2, put here 4. Now by putting 2 here, 2, 4 and 1, these are called coefficients of the equations. This equation is now balanced. You can count the number of copper atoms that enters the chemical reaction: 2 copper atoms, N by 2, 2 by 2, 4 nitrogen atoms, 2 by 3 by 2, 12 oxygen atoms, 2 oxygen atoms, 8, 4 by 2, 8 and 2. The sum now is 12 oxygen atoms. Now this element is balanced. What is a chemical equation? Chemical equation is an expression which expresses the chemical symbols and formulas of the reactants and the yield or products from this reaction. Yield means products. Or you can say that chemical equation is a method of expressing the symbol, formulas, and amounts of reactants, products, and the reaction conditions. Some chemical reactions occurs in the presence of special conditions. We put these conditions on the arrow, above the arrow here in this place. Here are some types of chemical equations. This is called Speish equation. As it is clear here, this is Speish equation: sodium hydroxide solution plus hydrochloric acid solution, acid and base, form salt, sodium chloride, and water. This equation is non-symbolic equation or Speish equation. This is one type of equation. The other type of equation is called symbolic equation. Symbolic equation is obtained from the non-symbolic equation by replacing the names of substances by symbols and the states: solution, aqueous. The third type of equation is called ionic equation. This equation is obtained from the symbolic equation by ionization of all substances denoted by aqueous. In the presence of aqueous solutions, solutes or substances, like sodium hydroxide, for example, in aqueous solution, dissociates into positive and negative ions. In the same way, aqueous hydrochloric acid is ionized or dissociated in water into hydrogen ions and chlorine or chloride ions. Sodium chloride aqueous solution dissociates or ionizes into Na plus and Cl minus. Water is not aqueous solution, it's a liquid, so it remains as it is here. So if you want to get the ionic equation from the symbolic equation, just ionize all compounds that are aqueous, only aqueous, not liquids, not solids, not gases. Only aqueous solutions are separated or ionizes into positive and negative ions, like that here. Finally, the fourth type of equation is called short ionic equation or final equation or short ionic equation. We can obtain this equation from the ionic equation by simplification. How? We can cancel Na plus and Na plus, cancel them together, cancelled, and also Cl minus. These are called spectator ions. These ions are the same. When they enter the chemical reaction, they are ions. When they get out from the chemical reaction, they are also ions without any change. So we cancel them. Only OH minus and H plus here remains, and water, and these are cancelled together. So this is called short or abbreviated chemical equation or a brief equation, short equation. In this way we can make another example: sodium hydroxide and sulfuric acid. In the same way, sodium hydroxide NaOH, sulfuric acid plus H2SO4 and an arrow, sodium sulfate Na2SO4 plus liquid water H2O. Then we balance this equation to get the symbolic equation. From the symbolic equation we can obtain the ionic equation by ionization of sodium hydroxide aqueous and sulfuric acid aqueous, first balancing them, then ionization, plus minus here and put here, then cancel the spectator ions to get the short equation. This equation we will obtain here is an equation like this exactly. This is the final equation for all the reactions of acids and bases, and since here is base and acid, we will get also an equation similar to that. OH minus plus H plus gives H2O. Here the same answer is here, but here different, slightly different, and here is slightly different, and so on. That's all we can say today. Till we meet again, we say goodbye.